Hello friends, today I will discuss the repulsion type moving iron instrument. In this, the points that I discuss are necessity of this, definition, construction, principle, operation, advantages, disadvantages, and its applications. First, let me discuss about necessity of this instrument. Whenever AC parameters like voltage and current are to be measured with a reasonable accuracy, then this type of meters are necessary because their cost is very less. Next, coming to the definition, any meter that uses repulsion of vanes to measure the RMS value of AC parameters, that is called repulsion type MI meter. Let us see the next construction of this repulsion type moving iron instrument. In this instrument, basically there are two major components. One is called the fixed coil, the other is two soft iron vanes. So in the two iron vanes, one is fixed to the body of the iron over which the coil is wound. The other is connected to the spindle of the meter, which is called the movable vane. In the diagrams looks like this. This is the cross-sectional view. This is the former. So inside there is a metal, and outside this former the winding is wound. That winding carries the current to be measured, and this is the spindle. This spindle carries the pointer like this. This pointer moves over the scale, and this spindle is also connected to the spring for having the control torque. And there is another vane which is attached to the body of the soft iron of the former like this. This is a movable vane that is attached to the spindle, whereas this vane is called the fixed vane. So that can be easily understood from the top view of the instrument. This is the pointer and this is the scale, and the scale is not uniform, initially compressed, and when it comes to the end it is expanded. And here it is the fixed vane or fixed iron which is attached to the former inside, and outside the former this is the winding, and that winding will carry the current to be measured, whereas the moving iron is connected to the spindle, means this. So this fixed iron or fixed vane and moving vane are going to be magnetized with similar polarity whenever AC current flows through the coil to be measured. During the positive half cycle of the AC, suppose here it forms south pole, here also it forms south pole, and the other side it becomes north pole, and this becomes north pole. So like poles repel each other. So the moving iron means this moving vane will move away from the fixed vane, that is in the clockwise direction, and the pointer moves over the scale to indicate the current that is flowing through the coil. So here is the actual diagram, the real diagram. So here is the fixed vane, whereas this spindle carries the movable vane, and this is the pointer and this is the spring which provides the control torque. and this is the scale that can also be seen in a real ammeter like this. So look at this scale here. The scale is compressed at the beginning, whereas when it goes to the in the middle, it becomes expanded. Again, when it goes to the end, it is slightly compressed. So next, coming to the principle, whenever current flows through this coil is going to get magnetized, and then will provide the magnetic field inside this former. Then that magnetic field will induce poles in the vanes, fixed vane and the moving vane with like polarity. So because the vanes are have the like polarity, so then these two vanes will move away each other, that is repulse with each other, and that repulsion is directly proportional to the square of the RMS current flowing through the coil. So let us see the operation. When the current flows through this coil, then that provides the magnetic field, and then that magnetic field will magnetize the fixed vane and the moving vane. During the positive half cycle, suppose the fixed vane polarity is south pole here and north pole here, then the moving vane magnetization polarity becomes, this will become south pole and this become north pole. Because south pole and south pole are here, they repel each other. Similarly, during the negative half cycle of the AC current that is flowing through the coil, suppose in the fixed coil, the north pole is formed here, then automatically south pole will be formed here. And in the movable vane, the north pole will be formed here and south pole will be formed here. So here north pole and north pole, again there is a repulsion. So that is, the pointer will move always in the one direction, that is from left to right, irrespective of the current direction in the coil. So what are the disadvantages with these meters? So their scale is non-uniform, which are already observed, and errors are introduced due to the change in frequency of AC supply. Similarly, there are errors due to the hysteresis and stray magnetic fields, and the power consumption is also high in these instruments. Coming to the advantages, this repulsion type of MI meters are available at low cost, and they have the high torque to weight ratio. Similarly, they can work on both AC and DC. Next, coming to the applications, repulsion type moving iron instruments are used to measure high range voltages and currents using the instrument transformers, that is a potential transformer and current transformer. And they work like voltmeters and ammeters, and these voltmeters and ammeters can be used both in AC and DC. Let me summarize once about the repulsion type moving iron instrument. So we observed here what is the necessity of this instrument, and we have seen what is the definition of the moving iron instrument, and then we have seen what is the construction of the instrument, and we have seen what is the principle of it, and we have seen what is the operation of that, and advantages of the moving iron instrument and disadvantages of the moving iron instrument, and applications of the moving iron instrument.